Hey y'all. Since we're in the middle of a series on weather, clouds, rain, lightning, all the fun stuff, we wanted to revisit how rainbows work, why they look the way they do, and we got a special request for this episode from Adriana, the cosmetic chemist. So thanks, Adriana, for that suggestion. And if you have a suggestion of an old episode that you love and that you want to hear again, please feel free to reach out to us.
This one's super cool, and like a lot of our older episodes that have been like a year or more ago, there could be a bunch of you guys who've never heard it. And so that's another reason why we do this, obviously. So please check this episode out. You probably didn't know we had one about rainbows and mirages. So check it out, and it's perfect in our series that we're already doing. So we'll be back with a new episode next week.
And I gave Jim a little spoiler, so he actually knows this already, although normally he doesn't. That episode, as part of our series on clouds and the weather, is going to be about lightning. So that'll be really fun. Be sure to come back and check that out. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast to help you understand the chemistry of your everyday life.
Jam, what's up? What's up?
Oh, nothing.
Just hanging out, recording.
Yeah. Getting ready for the new year, you know?
Yeah, mentally preparing.
Yeah.
Jam, have you ever been driving?
Yeah, I have.
And has it ever been hot?
Yes, very much so.
Has it ever looked like there was maybe water on the road
Yes.
off in the distance?
Yep. Shimmery, kind of weird water.
And then you get there and it's not there?
Yeah.
That's known as a mirage.
Or you never get there. It's like it's always there, but you never get there.
That's true.
You know, if it's a straight enough
Yes.
road,
Mm-hmm.
and you're like, man, thought this was going to run directly into some water, and it never is. Where the water's still further away.
Mm-hmm. Well, that is something we're going to talk about today. We're going to talk about that weird mirage that happens.
Okay.
But first, we're going to talk about something a little bit more for everyone who can understand is rainbows.
Okay.
And we're going to talk about what those things and pretty crystal vases all have in common.
Okay.
Okay.
Interesting.
Great. So I told you already know about the rainbows part of our topic today. Because
Right.
we were all sitting around talking about it.
Mm-hmm.
And I said I wanted to do an episode on rainbows.
Yeah.
And someone said it was dumb because everyone learns that in second grade.
For the record, I was not the one who said that.
No, Jim was not. Someone else said that.
Mm-hmm.
And I was like, okay, fine. But do you guys know why rainbows are in the order of color they are or why they actually happen other than just this very basic answer that you've all learned from years ago? And my favorite answer was Emily said, they're in that order because it's Roy G. Biff's name, which made me laugh. But I didn't really get a good answer.
Yeah.
So I want you and our listeners at home to take a moment and think through what you know about why rainbows are the way that they are.
Okay.
Okay. What'd you come up with?
Okay, here's my theory. We've talked about the electromagnetic spectrum before.
Mm-hmm.
There's there's different types, quote unquote, of waves. Some that we can see, some that we cannot, some that have different effects on the world around us.
Mm-hmm.
In the range of visible light, it starts with red and ends with violet. And so
That's correct.
there's it does fade from color to color. It's not like there's only red and then a chunk of red, a chunk of orange. The rainbow is gradual.
Mm-hmm.
And so it fades across all those colors
Mm-hmm.
that are on that spectrum. So my thought is not that it's not just that it's pretty or something or whatever.
Mm-hmm.
It's just that's the range of colors we have for visible light. So we see that when a rainbow happens in that order because that's the frequencies, the red being the lowest, violet being the highest.
Great. That's a good guess. And then what else do you know about rainbows?
I know that we talked about color a lot when I was really, really into art and painting and stuff like that, with the color wheel and things like that. But also I remember from science classes that white light is a combination of all the colors,
Mm-hmm.
and that rainbows are basically just a separation out of white light in some way
Mm-hmm.
into the elements that it is made up of. It's made up of all the colors
Do you know why it gets separated out?
because it's trying to show off. I don't know.
I was really prepared for you to give a real answer, so that one got me off guard. Okay, so your explanation is really great. For that being a guess, it was really good.
Nice.
So light is made up of more than just what we can see,
Uh-huh.
but white light is made up of all the colors of the visible region. So what happens in rainbows is the white light moves into water and other light, presumably as well, that we can't necessarily see. Moves into water.
Like droplets of water in the air.
Droplets
of
of water in the air. That's what usually happens after it rains.
Uh-huh.
Or maybe on the ground, or who knows. Moves into water, and light travels at different speeds in different mediums.
Oh, okay. That's weird.
So light traveling through the air can move faster than light traveling through water.
Okay. Interesting.
So when the light moving super fast through the air hits the water and it slows down,
Uh-huh.
light, which is made up of waves, which are oscillating back and forth
Mhm.
things, when it hits the water and it has to slow down, it actually gets bent slightly.
Oh.
I think it's due to when the wave enters and it's going to bounce back now in a different direction. And as it hits this new medium, the way the waves are bouncing is now impacted. And so it comes in at a different angle than it had been moving through the light.
Huh. Interesting.
Mm-hmm. So because each color then has a different wavelength, when it enters the new medium, when it's traveling through air and then it hits the new medium, each wavelength will be affected slightly differently. So they're going in a straight line. The waves hit the water and they suddenly slow down and they're kind of pushed off at an angle. And now each one is slightly different angles based on the shape of their wave already, based on the wavelength that they already had.
Okay.
And that naturally spreads all the colors out in the order, like you mentioned, that they are in the electromagnetic spectrum, because that has to do with their wavelengths already.
So let's say each color
Mm-hmm.
is a snake.
Great.
I like it because that's what I think of when I see those waves as they're drawn for us.
Mm-hmm.
So each of them are a snake, and they're all traveling together, but obviously some are faster than others because that's what wavelength is. It's like they're slithering, their slithers are faster and
Yes.
closer together or whatever.
So there are more close together slithers on some and wider slithers on others, but they're all going the same speed.
Right.
Mm-hmm.
So all those snakes, all seven, what is it? 7 snakes are traveling.
Yep.
And they are traveling super fast. They
Mm-hmm.
travel right into some water.
Mm-hmm.
Boom, that's surprising. Uh-oh.
Mm-hmm.
This is not what we expected. And their slithers are all different.
Mm-hmm.
And when they hit the water, it affects them all differently. This analogy is definitely not going to work forever, but I'm going to try to ride it hard all the way till it breaks apart.
Uh-huh.
So they hit the water, and then they're all like, what the? And they're all disrupted.
Mm-hmm.
And the ones who are slithering faster and the ones who are slithering slower, or like their movements are faster or slower,
More slithers, less slithers, or whatever.
Yeah.
Mm-hmm.
are all naturally, just imagine literal snakes hitting literal water, naturally going to be affected slightly differently.
Yes.
Maybe it's like some of them have a slightly easier time entering this new medium or something, or like or some of them aren't, or whatever. Either way, it's going to be like, so they've all been together, and now the one that has quicker slithers, maybe he goes through more quickly or something, or they just get broken apart.
It's more like they just get broken apart than one goes through more quickly. Yeah.
So they're all hugging.
So they're
and
all
when they
in
hit
a
the
nice
water,
line.
Yeah.
Then they hit the water and it becomes like an arc. They're all going in different directions. A
They're
wide
like-
V, and they're on all throughout the V.
They're all like, dang it, we hit the water. And then they can't hold on to each other anymore.
Mm-hmm.
And it's like,
So they spread out, but they stay in order,
yes,
but they spread out.
to stay in order. Man, that analogy definitely doesn't work forever, because
No,
those
it
snakes,
sure doesn't.
those snakes, unless they're really good swimmers, would definitely get out of order.
But you have seen things be impacted differently by the medium they're in. So imagine a swimmer who's very aerodynamically small, moving very quickly through water, and then someone who's like splashing, making lots of splashes, and is more wide, maybe is going to move slower through water because there's more natural resistance. That's why they say that some swimmers shave their legs so there's even less things resisting. Maybe the wider, slowers or waves are resisting differently, so they all get bent at slightly different angles. They just move differently through the new medium.
Yeah.
And that results in then coming out on the other side differently.
And even though they're all in the range of visible light, pretend like there's no such thing as visible light. All the different wavelengths behave differently. We already know that about like microwaves and infrared and ultraviolet. We know they have different effects on the world. So pretend there's not even a visual aspect to it. Waves of anything hitting anything, we already know are going to behave differently. So even though those are tightly close together in our minds because they make up what we see, it's not weird for different types of wavelengths to behave differently under the same conditions.
Right, exactly.
So it's not like weird.
Right. So that's rainbows.
It's not weird. You made it weird. I think it's fine. I think it's normal. You guys, you snakes, like, don't be embarrassed, okay? It's fine. I think it's fine. I'd be disoriented if I hit water too.
Exactly. Okay, so that's it. That's the overview of rainbows.
Okay.
But there's some other things we're going to stir in there.
Okay.
One is, we talked about crystal glass, and the other is mirages. I'm saving mirages for last.
Okay. I like that.
This idea that light moves differently through the water and then through the air and through all these different substances can be summed up with the idea of the index of refraction, which is basically a measure of how it moves differently, where it travels faster or less fast.
Okay.
So light travels differently in water than air. It travels differently in glass. It travels differently in glass with different substance. It travels differently in hot air than cold air. Light travels differently. All these things have different refractive indexes or index of refractions. So that idea comes into play also in crystal glass. So
crystal glass.
Regular glass is cool. It's see-through, whatever. But my mom had this really pretty vase that was a crystal vase, and it was more rainbowy. It just reflected the light differently than regular glass did.
We can I ask a question real quick. It's not crystal really, right? It's just like a term.
Right.
Like That's
what I'm about to say.
Okay, cool.
So that vase was known as crystal vase.
But that's just a marketing term or something.
That is a marketing term usually applied to, and there could be other types of glass that are also known as crystal, but leaded glass. It's glass that has a higher lead content than other glass.
Interesting. That's weird though, because you think it'd make it look less something. Like, I don't know what all lead would have an effect on, but it seems like it'd look muddy or something like that. Like, oh, you have some grayish glass. Is what I would assume would happen if you put lead into glass. Right.
You would think that would happen, but actually all it does is change essentially the refractive index of the glass. So light moves differently through leaded glass than regular glass so that it does look more sparkly. It has...
Is it slower or faster than regular glass?
It's slower.
Okay. Interesting.
It moves through the glass slower than regular glass because it has that lead content. I think it makes it... This gets into the question of whether glass is a liquid or a solid, but I think it makes it slightly more viscous, and so it makes it harder for the light to travel through, so it refracts it more.
So it is kind of like whenever it's hitting a prism, and it breaks it apart. But basically, you've made it to where you've made a cup or a vase or whatever that has that effect kind of all over it, so it'll look all sparkly.
It's almost just like when it hits water.
Interesting.
So that's another place we see the refraction of light. But the craziest one to me, the most interesting to me, that I knew the least about, thanks Scientific American for teaching me, is that thing you see on the road that looks like water far off is as a result of the refraction of light.
Okay, that's interesting. I thought it was just like heat or something.
like heat waves or whatever.
Yeah.
Right. Well, we have our hot ground, and on this hot day,
Mm-hmm.
the air there by the ground is going to be hotter and less dense
Okay.
than maybe the air above it.
Okay.
So because it's less dense, it'll have a different refractive index. It'll move light differently.
Just like water is more dense than air
Mm-hmm.
with the light hitting it.
Right. So the light will take a curved path as a result of the changing density from the sky to your eyes. The wavelengths of the eye will take the curved path, and then we're getting those sky light particles coming at a different angle than our brain's expecting it to. So our brain attributes that to water on the ground.
Interesting.
Mm-hmm.
The light's curving
Mm-hmm.
with the air. So we've experienced that in the previous two examples where the actual substance is changing.
Mm-hmm.
It's hitting water or it's hitting glass.
Mm-hmm.
But in this case, it's just different densities of air.
Different temperatures and densities of air have a different refractive index.
Whoa, that's weird. It's also crazy then that like our eye is not seeing what's real.
I
Like
think it's your brain that's not seeing what's real.
well, both things.
Yeah.
The lights, because the light is wrong.
Yeah.
It's hitting us.
We can't account for the quantum mechanics of light.
Yeah. Like the light is, our brain is trying to make sense of it,
Mm-hmm.
but we are receiving light in an unnatural thing. The fact that it's curving.
Mm-hmm.
Like, and that's kind of crazy to me.
Yeah, it is kind of crazy. The quote I learned about this mirage from the Scientific American article. It was an interview with a professor, Dr. Meyer at Baldwin Wallace College.
Mm-hmm.
And my favorite line was, the illusion comes from the fact that quantum electrodynamics is not intuitive. And the brain assumes that light travels in a straight line.
Mm-hmm.
And I just like that. Our brains are very smart and help us do a lot of things, but they can't account for the fact that sometimes light curves.
Yeah. Okay, I have a story about this.
Okay, I'm ready.
So I was too young. So this is a family story. This is not one that I really remember. My older brother, I was alive though. My older brother, 6 or 7 at this time, learned about mirages for the first time. He asked about it. In Texas, you see them all the time, especially West Texas. There's tons of straight, long roads.
Oh my gosh, yeah.
And a lot of heat to make these mirages all the time. So he asked about it. My mom kind of just gave him a little like, oh yeah, it's not really water. It's just a trick or whatever.
Mm-hmm.
And so he learns about that. And then one day we're driving in our car down this road. There's like this reservoir that is just for a source of water. And it's a super not pretty at all
Mm-hmm.
lake pond reservoir thing in Abilene, known as Kirby Lake, Kirby Pond, whatever you want to call it. And in very, very, very innocent, but honest and insulting
Mm-hmm.
comment, my older brother was like, oh my gosh, that is the biggest mirage I've ever seen. When he saw it, looked down, because it's the very end of this road.
Uh-huh.
And he was just like, whoa.
Oh.
Just in awe. And it's like, oh, sorry to tell you, that's actually our water reservoir.
That's what we drink.
Yeah. And it does look like a big mirage.
That's so funny. I just realized, I'm not sure he said at the beginning, but rainbows come in the arch because light's diffracted from the raindrop. And if there was no earth on the bottom of our view, they would be full circles.
Whoa, the earth's getting in the way.
Mm-hmm.
Man, that's crazy.
So these are all the ways that light bends and can impact your life, or at least some of them.
Okay, so to basically explain the water one, sort of.
Mm-hmm.
So with the glass crystal, it's the same thing as
Mm-hmm.
water. It's just that you have taken glass and made it to where the waves go slower through it than normal glass.
Mm-hmm.
So it just looks a little bit sparkly, rainbowy, or there's more color to it
Mm-hmm.
because you slow down the light a little bit with the lead.
Right.
And then in the mirage situation, it's the same thing, except
Except
rather than being broken apart by hitting something like water or glass, it's just hitting a different density of air and curving to account for that.
Right.
Because it wants to be in the least dense area, right? So it's
It
like
wants to take the fastest path.
the fastest path. So it's like all this light's coming at your eye, and it hits this zone of super nice, low density, warm air, and it's like, yes, please. You know what's funny is that it's like a highway for light particles.
Yeah, that's a good way to think of it.
It occurs on highways.
The light particles taking the highway messes up your own view of the highway.
Yep. And then our brain is trying to make sense of it. And so it's like, well, it's kind of like water, because water reflects the sky. These sky light particles are what I'm seeing, but I'm seeing them on the road. So it must be water.
Yeah.
And then it just looks like water to us.
Very cool, huh?
That's really weird.
And usually the sparklier things are, in my experience, the sparklier things are, the higher refractive index they have. So I think diamonds have an even higher refractive index than lead glass. And I think both of those things are higher than water.
Yeah.
So the refractive index is higher for the sparklier things.
Interesting. I think that's crazy.
Yeah. Isn't that cool?
Yeah.
You can bend light and see all kinds of crazy things.
Man, we can do a lot of stuff to light.
Yeah.
A lot more than I thought.
Well, thanks for hanging with me and learning today about science and light.
Anytime.
Is there anything that's happened to you this week as we enter the new year?
So my family's always late for everything. And so we will be celebrating the kind of Christmas time holiday later, typically around New Year's time or so. So that is what we'll be doing.
That's what you'll be looking forward to?
Yeah.
I always really enjoy setting new goals around New Year. And they're not New Year's resolutions because I think those are usually pretty silly.
Yeah.
But I think through my year and I think through what would I like to accomplish this year. And then I look back at last year's. And one is always that I always have is try something new. And if I can, sometimes I'm financially inhibited for the second one, but go somewhere new. And then I usually have some financial goals like by this time I want to have this much saved or
this many million, that kind of thing.
Yeah, that much definitely is how much we're dealing with in my life.
Yeah.
And I was thinking through my goals from 2019 and I was able to do a lot of them that I'm very excited about. And I tried so much more than one new thing.
Yeah.
I learned how to ice skate, which is one of the most exciting things I've done. If you think you'd love a sport, but you're afraid to try it, just do it because it was so fun.
Or anything, not necessarily a sport.
Yeah,
you don't have to go stoop down into sports if you don't really want to.
Well, ice skating's a pretty good sport. It's not as negative as your other sports, right?
That's true. Yeah. It's good to be active. Okay.
It's good and active. I also just went ahead and started this podcast, and that was really cool. I started volunteering at the Pro. I've just been able to do a lot of new things.
Yeah.
And I got to leave the country for the first time and travel to a new place with my mom, which was really special.
That's crazy that was this year. It feels like a while ago that you did that.
It was all this year.
Yeah.
And so I'm really excited to look forward and plan some of my goals for next year. And it just seems like the years keep getting better, you know?
And what's kind of cool about you having such a success story about your year goals is that I was reading something about like resolutions people make. And it said that people super often overestimate what they can accomplish in a year. And at the same time, way underestimate what they can accomplish in a month. So it's like we're bad at both. We think the short term, not much can be done. We're like a month, that's not a ton of time, blah, blah, blah.
Right.
We kind of lower our standards for that, or we just lower expectations. A year, we were like, well, I'm going to do this, I'm going to do that, blah, blah, blah. Sky's the limit. And then we don't accomplish any of it. So it's like such a weird human psychology tendency.
Well, and a lot of them are things that I know are coming anyway. So one year, I know I was taking my qualifying exams, and on my goal, it was just
start and do the best I can on those. And in a way it says, oh, that's inevitable.
Yeah.
I'm going to have to do that if I want to graduate.
Yeah.
But it's still a big thing that's coming and I want to do it well and
Right.
prepare for it, you know? So I think I plan my goals or things that I'm trying to get done in this year kind of differently than some New Year's resolutions, because some of them are, yeah, this is probably going to happen anyway, but I'm hoping to finish it this year.
Yeah.
You know, and so it's gone really well.
Yeah.
I've really enjoyed that. And it helps me get an opportunity every year to look back at my past year and think of all the really cool things I've been able to do.
Yeah.
So
That's cool.
it's always nice.
Taking stock.
Yeah. Well, we hope you guys have a good and safe new year. And thank you guys all so much for listening and joining us today.
Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you. So if you have questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share thoughts and ideas. If you enjoy this podcast, you can subscribe on your favorite podcast app. And if you really like it, you can write a review on Apple Podcasts. That helps us to be able to share chemistry with even more people. And if you'd like to help us keep our show going and contribute to the cost of making it, go to ko-fi.com/Chem for Your Life and donate the cost of a cup of coffee.
This episode of Chemistry for Your Life was created by Melissa Collini and Jerem Robinson. References for this episode can be found in our show notes or on our website. Jerem Robinson is our producer, and we'd like to give a special thanks to V. Garza, who reviewed this episode.